Warm Chemistry. For this video, is the part 3 video of your topic 1.1 where we will discuss 3 things, and the first thing will be your average atomic mass. Second, we will talk about relative atomic mass where the symbol is your A, R. Third, and last but not least, we will discuss relative molecular mass, which is your M, R. In this video, we will have a lot of calculation, therefore make sure you have your pen and papers and calculator ready. And make sure you try the example with me. So let's jump straight into average atomic mass. What is actually average atomic mass? The formula of average atomic mass is this, where the average atomic mass will be equals to summation of Qi times Mi over summation of Qi. What is actually Qi and Mi? Qi is the relative abundance of an isotope of the element. Abundance over here means how much do we have? We know that some of the element might have a few isotopes. If you remember, we have your hydrogen 1, we have hydrogen 2, we have hydrogen 3. So every isotope over here will have a different amount of abundance. How much is hydrogen 1, how much is hydrogen 2, and how much is hydrogen 3. So that is represented by the Qi, where we know that Qi is the abundance of each isotope. Next, Mi. From the word M and I, we know that is the isotopic mass. Alright? Summation over here, the symbol of summation is actually the symbol of total. So, total of Qi times Mi and also the total of the Qi. So, this is the formula of average atomic mass. Don't worry, we'll learn how to use the formula. Okay? And the unit of the average atomic mass is AMU or U. Both is acceptable. You can write in the form of AMU or you can write in the form of U. But make sure the unit is a must over here. Alright? You must have the unit down when you are calculating average atomic mass. So make sure you remember the unit. And that's it. That is the things that you need to know about average atomic mass. You basically need to memorize this formula. And I'll teach you how to use this formula in the example later on. And also, make sure you remember the unit. The unit of average atomic mass can be written down as AMU or U. Okay? As simple as that. That's it. So, let's jump straight into example. The first example of this question is your chlorine. You can see over here, chlorine having 2 isotopes, chlorine 35 and also chlorine 37. Having the isotopic mass given in the unit of AMU. Isotopic mass means this is your Mi. Okay? Next, you have the relative abundance. Relative abundance of the chlorine 35 is 75.8%. And another one is 24.2%. And if you realize, since chlorine only having 2 isotopes, therefore, the total of the abundance must be 100%. You can work it out. 75.8 plus 24.2 is your 100%. Because chlorine only having 2 isotopes right now, so the total of the isotope must be equals to 100%. And the relative abundance over here is your Qi. Alright? And the question asking for average atomic mass of chlorine. So how do we work out the average atomic mass of chlorine? Simple. We always start with the formula and make sure you write the formula down because there will be 1 mark given. So start off with the formula. Average atomic mass of chlorine equals to total of Qi and Mi times over with the total of Qi. So, by having this formula and also all the value given in the table above, you can just put into the formula and calculate the average atomic mass of chlorine. So, the first one is 75.8 times with 34.969 plus with 24.2 times with 36.966. That is the first part of the formula. And next is the total of Qi, where the total of Qi is 75.80 plus with 22.20. Okay, make sure you're holding a pen and paper and do it together with me so that you can understand how it works. So, mathematics concept, you solve the multiplication first and then only you add them up. So, you solve the mathematics, you realize that, and the final answer will be 35.4523, and the unit, because it's an average atomic mass, therefore the unit must be in AMU or U. And that is the final answer of average atomic mass of chlorine. Make sure you have the formula down because the formula will be 1 mark. The substitution and also solve the mathematics. And make sure your final answer comes with the unit of AMU. And that is how we use the formula of your average atomic mass. How do we identify which one is your Mi and which one is your Qi? And how we find the total of the Qi, Mi. Okay? Simple. So let's look at the second example. In this example, magnesium has 3 isotopes. So you can see magnesium having magnesium 24, magnesium 25, magnesium 26. And the question stated that the average atomic mass is 24.305 U. In the other words, the average atomic mass is given. And what the question looking for? The question looking for the X and Y. So let's see where is the X and Y. The X is the isotopic mass of the magnesium 25. So we are looking for the Mi of magnesium 25 for the X. While for the Y is the percentage abundance of the magnesium 26 isotope. In the other words, the Y is the Qi. So, slightly different from the example 1 just now. In this example, we are looking for the Mi of one isotope and Qi of another isotope with the average atomic mass given. Okay, can you see the difference? But the question is still talking about average atomic mass, Qi, and also Mi. So, we will still be using the formula of average atomic mass. And in the X and Y, which one do we calculate first? Obviously, we will be looking for the Y first. The reason is because the percentage abundance, we know that, must give rise to a total of 100. Because magnesium right now having only 3 isotopes, and the total of the abundance of 3 isotopes must equal to 100%. Therefore, to calculate the Y is as simple as Y equals to the 100% is the total minus the 78.99 and also 10.02. And that will give rise to your Y is equals to 10.99%. That will be the isotopic abundance of the magnesium 26. Alright, simple? So next, we'll be calculating the X. Knowing that your Y just now is 10.99 from the previous slides. So now we need to calculate the X. We are looking for the X right now. Starting off with the average atomic mass first. Therefore, the formula of average atomic mass must be written down. The total of Qi Mi over the total of Qi. Put in the value. We know that the average atomic mass given is 24.305 U. So put it down. So we know that the percentage abundance, that is your Qi. Isotopic mass, that is your Mi. So the first pair is for the magnesium 24. Put in the value. The second pair is for the magnesium 25, where the Mi right now is X. So you have 10.02 times X. That will equals to 10.02x, alright? Plus, with the last pair is magnesium 26, where the Y calculated is 10.99. So the isotopic abundance is 10.99 times the isotopic mass. Over, so the total of Qi is all this. Solve the mathematics, then you will find out. And just a kind reminder, this is the x that we are looking for. Alright, we need to solve the mathematics and to get this x. This is the unknown that we are looking for. Therefore, to solve the mathematics, we'll bring over the 100 and total out what you can. So we can total out this and this. Then it will give rise to, and this is the x that we are looking for again. Alright, so solve the mathematics and get the x. And the x calculated will be this. Bear that in mind, x is the isotopic mass in the unit of AMU. Alright, therefore, the final answer must come with the unit of AMU. So this is the final answer. And this answer is correct and makes sense. Why? Because the value that you calculated for the x is 24.9876, which is close enough to magnesium 25. I hope you realize that when the isotope is magnesium 24, the isotopic mass should be close enough to 24. When the magnesium 26 isotope, the isotopic mass should be close enough to 26. Since we are looking for the isotopic mass of magnesium 25, therefore, the x calculated should be close enough to 25. That is the tips over here. Alright? All the isotopic mass should be close enough to the isotope itself. Okay? Simple. Let's try another example. So in this example, you're having a mass spectrum of silicon. Question asking for the average atomic mass of silicon. So we come across a new thing over here. Mass spectrum. What is actually mass spectrum? This is your mass spectrum. Okay? And obviously, the y-axis over here is your relative abundance, and the x-axis over here is your mass over charge. Your relative abundance, we know that that is your Qi. And what is all this line stand for? And what is mass over charge stand for? Before we answer this question, let's look into one thing. Mass spectrum. What is actually mass spectrum? We know that mass spectrum looks something like this. Let's start off with your y-axis, knowing that your y-axis as your relative abundance over here, relative abundance or percentage abundance. In the other words, your y-axis will be your Qi, alright, your isotope abundance. So all this value is your isotope abundance, okay? Next is your x-axis. Your x-axis will be normally labeled as mass to charge ratio, or M over E. The M over E is also your isotopic mass, or nucleon number, or mass number. All that is the same. And all that represent your x-axis is actually your Mi. So that is your isotopic mass of 28 for silicon, silicon 29, and silicon 30. Okay, so that is the mass spectrum, y-axis and x-axis. Last but not least, the number of peaks over here will represent the number of isotopes. So how many isotopes silicon having? Silicon right now having 3 isotopes. Look at the peak. I have 1 peak over here. That is my first peak for silicon 28. The second peak, silicon 29. The last peak, silicon 30. So over here, silicon having 3 isotopes. Okay? So if I have 4 peaks, then I will have 4 isotopes. If I have 5 peaks, then I will have 5 isotopes. The number of peaks that you have in your mass spectrum represent the number of isotopes you have for that element. So this is everything that you need to know about mass spectrum. Let's answer example 3. So from everything that we have learned about mass spectrum, we know that the relative abundance over here, that is your Qi. And this is actually your Mi. Okay? Question asking for, calculate the average atomic mass of silicon. So we will start off with the formula, of course. So the formula of average atomic mass of silicon is equals to the total of Qi Mi over the total of Qi. So the first pair will be your silicon 28. So that is your Mi if the specific isotopic mass is not given, then we will take the nucleon number as the isotopic mass. And for this pair, the abundance of silicon-28 is 0.9223. Therefore, the first isotopic abundance for 0.9223 times with 28 plus. The second pair is for silicon-29, so the isotopic mass right now is 29. And the abundance is 0.0457. Last but not least is your silicon-30, where the isotopic mass will be 30, and the Qi, the relative abundance, will be 0.0310. So that is the total of Qi, Mi of all three silicon isotopes over with the total of Qi. So all this is the total of Qi. So add all this Qi and solve the mathematics. And make sure your final answer comes with the AMU or U, because it's your average atomic mass of silicon. Alright, and that is how we use the mass spectrum. Knowing that your y-axis is your Qi, your x-axis is your Mi, using the same formula, solve the mathematics carefully, pressing your calculator carefully, and you will get the final answer and make sure it comes with the correct unit. Simple. Alright, and that's all about average atomic mass. Simple, easy, very simple formula. Next, we'll move to relative atomic mass. What makes average and relative different? So, over here, I have relative atomic mass, and the best thing is relative atomic mass, you can use symbol. So that is the small r represent relative, A represent atomic. Okay, so that is your relative atomic mass symbol. The formula of relative atomic mass is as given. Your relative atomic mass AR is equals to the average atomic mass of one atom of the element over 1/12 times mass of one atom of carbon-12. Don't worry, we'll learn how to use this formula later on. Alright, it's very simple. Let's understand the formula first. What is meant by average atomic mass? The average atomic mass that you have part of this formula represent the formula that we used just now. So in the other words, to calculate the relative atomic mass, to find the relative atomic mass, you must first calculate the average atomic mass. So you must calculate the average atomic mass so that you can calculate the relative atomic mass. Okay, that is your first step. Second, the mass of one atom of carbon-12 is actually 12 AMU. In the other words, here should be your 12 AMU. Okay, and 1/12 times 12. You realize that you can cancel off the 12. Last but not least, the relative atomic mass has no unit. Okay, relative, whenever you have the word relative, that means there will be no unit. Therefore, the final answer should have no unit. Okay, a bit of tips over here. The value that you calculate for the average atomic mass is actually the same as the value for the relative atomic mass. For example, if the average atomic mass that you calculate is 10 AMU, then for the relative atomic mass, it will be 10. Alright? Because the main difference between them is the average atomic mass having the unit of AMU or U, but the relative atomic mass has no unit. But the value is actually the same. Why it can be like that? Simple. If the average atomic mass calculated right now is 10 AMU, so you put in the 10 AMU over here to calculate the relative atomic mass. And we know that the average atomic mass must be over 1/12 times mass of one carbon-12. And we know that one carbon-12, the mass is actually 12 AMU. So mathematic-wise, 1/12 times 12, so the 12 cancel off. So you have 1 AMU left. AMU cancel off. So you realize that the relative atomic mass calculated is 10. So can you see the difference over here? The average atomic mass is 10 AMU. The relative atomic mass is 10. So the main difference between the average atomic mass and the relative atomic mass is the unit. That is the reason why average atomic mass is so important to have the unit down, while the relative atomic mass must have no unit. This entire formula of the relative atomic mass is to cancel off the unit of AMU or U. Even though the formula is only to cancel off the unit, but whenever the question asks for the relative atomic mass, you must have the formula down. So you must be able to write the formula. And last but not least, read the question very carefully. You must make sure the question is asking for average or the question is asking for relative, because that will change your final answer coming with unit or not coming with unit. Simple? Let's try the first example. There are two isotopes of bromine. So I have two bromine over here, which is bromine 79 and bromine 81. And for this question, the bromine 79 and also bromine 81 come with the specific isotopic mass. So make sure you put down the isotopic mass for bromine 79 is 78.918. While for the bromine 81 is the 80.916. That is the Mi for your bromine. While the percentage abundance over here obviously is your Qi. So you have the Qi given for the Br79 and also Br81. Question asking for calculate the relative atomic mass of bromine. So the question is asking for the relative atomic mass. But we know that in the formula of relative atomic mass, you must have the average atomic mass. So for the step 1, to calculate this question, you must calculate the average first. Then only you can put the average atomic mass that you calculated into your step 2 to find the relative atomic mass. So we will calculate the average atomic mass of this question first. So write the formula of average atomic mass. Substitute the value after you have the formula. The Qi for bromine 79 is 50.69. So that is the first pair. Plus with the second pair, which is 49.31, over the total of the isotopic abundance. So the total is these two, 50 plus 49.31. Solve the mathematics. The average atomic mass of bromine calculated is unit AMU. Why AMU? Because it's the average atomic mass. So whenever you have the word average, you must still have the unit. But the question asking for relative. So we need to change this average atomic mass calculated into relative atomic mass of bromine. First, by writing the formula. So the relative atomic mass of bromine is equals to average atomic mass of bromine over 1 over 12 times mass of 1 carbon-12 atom. The average atomic mass calculated for the bromine is 79.9032 that you calculate just now. Over 1 over 12 times 12 AMU, the mass of 1 carbon-12 atom. Solve the mathematics. 1 over 12 times 12, AMU divided by AMU. Therefore, the relative atomic mass of bromine calculated is 79.9032 without unit. And that is how you cancel off the unit. And that is what I mean by the relative atomic mass will be actually equals to the average atomic mass but without unit. Okay? Simple. Easy peasy. Alright, last example and also slightly tricky question where you are talking about rubidium. Rubidium having two isotopes here. Two isotopes with rubidium 85 with the isotopic mass of 84.9118 U and also rubidium 87 with the isotopic mass of 86.9092 U. Given the relative atomic mass of rubidium is 85.47, calculate the abundance of each isotope. So the question is actually asking for the QI for each isotope. Okay? So let's take out the data given in the question. First and foremost, the MI. The question gives you MI for rubidium-85 is, and for rubidium-87, the MI given is this. The QI is the one that you are going to calculate. So let's say the QI of rubidium-85 is X. The QI for rubidium-87 is Y. Okay? This is the one that we are looking for. Next, the question gives you the relative atomic mass of rubidium. So the relative atomic mass of rubidium given is 85.47 without unit. So you know that that is your relative atomic mass because there is no unit. Question asking for X and Y. It's not necessary to use X and Y. You can use AB, you can use PQ, it doesn't matter. So put down unknown for the isotopic abundance of the rubidium-85 and the rubidium-87. So that is my unknown X and Y. And since the question asking for the QI, we know that the QI will only be in the formula of average. Only in the formula of average we have the QI-MI over QI. Remember that? Therefore, we need to change this relative atomic mass given into average atomic mass so that we can find the QI. And how can we change the relative atomic mass into average atomic mass? Simple. Formula of relative atomic mass of rubidium will be equals to the average atomic mass of rubidium over 1 over 12 times mass of one carbon atom, 12. Put in the value of the relative atomic mass of rubidium is 85.47 equals to, solve the mathematics, 1 over 12, settle. The average atomic mass of rubidium will be equals to 85.47 U. This is the first half of the answer. You need to change the relative atomic mass into the average atomic mass because we are going to use this average atomic mass calculated to find the isotopic abundance of the rubidium-85 and rubidium-87. So by using the information that we have from the previous calculation, we are going to look for the QI for the rubidium-85 and rubidium-87. But before that, we know that rubidium right now having only 2 isotopes. Okay? Since rubidium having only 2 isotopes, the X plus Y, the abundance of the 2 isotopes, it must be equal to 100%. Or, to make the mathematics simpler, we can add up them to become 1. So the X plus Y can be equals to 100% or the X plus Y can be equals to 1. Which one is easier? Look at the question. The question only say calculate the abundance of each isotope. Did the question ask for percentage abundance? No. Therefore, we don't choose 100%. We will go for X plus Y equals to 1. That will make your mathematics easier. Okay, because the number will be a lot smaller. So right now, we agree on X plus Y, the total abundance for both isotopes will be equals to 1. And mathematic-wise, X will then equals to 1 minus Y. We will keep this aside first. We will be using this later on. Okay? Now, let's use the average atomic mass that you calculate just now to calculate the QI. So we start off again with the formula. So the average atomic mass of rubidium will be equals to. So this is the formula of average atomic mass of rubidium. We know that the rubidium calculated right now is 85.47 U equals to the QI for rubidium-85 is X. So you have 84.9118 times with X plus with the rubidium-87, which is 86.9092 times Y. So we have the X plus Y over here, over the isotope abundance total. Isotope abundance total is your X plus Y. And guys, we know that we have decided our X plus Y equals to 1. So X plus Y over here will actually equals to 1. And to solve this mathematics of X and Y, we need to make it into the same unknown. Therefore, I'm going to substitute the X equals to 1 minus Y into this X, okay? And right now in my problems, I only have one unknown, which is Y. Solve the mathematics, guys. So this is the Y that we are looking for. But be careful, this is a minus, this is a plus. So make sure when you press your calculator, you have included the symbol of minus and the plus over that. Therefore, this is the Y that we are looking for. And obviously, you can solve the mathematics right now. Just bring this over and you can get your Y. And Y equals to, you have the first answer, which is Y equals to 0.2795. So Y is the isotopic abundance of the rubidium-85, okay? But we have two unknowns. We have X and Y. How do I get my X? Simple. Over here, we know that X is equals to 1 minus Y. So your X calculated will be 0.7205. And this is the X calculated, okay? And what is your X? Your X is your isotopic abundance of the rubidium-85. See? Easy. So that is the way that we calculate the isotopic abundance when the element having only two isotopes. So you are going to make it as an unknown X and Y, P and Q, doesn't matter what unknown. But the trick over here is your X plus Y, or the total of the isotopic abundance, must be equals to 1 or 100. Okay, either one or 100%. And then you are going to use this to put into your formula and solve the unknowns. Simple. Alright, easy. And make sure in your final answer, you label which one is the isotopic abundance of rubidium-85 or rubidium-87 or any of the isotope. Make sure you label your final answer. Simple. And that's it about relative atomic mass. Let's move on to the last part of this video, which is relative molecular mass, which is MR. Okay, so the formula right now changes the MR. The formula is rather similar, but we are changing the word molecule. So the relative molecular mass, MR, will be equals to the average mass of one molecule over 1 over 12 times mass of one atom of carbon, 12. Similar, the relative molecular mass also has no unit. Guys, whenever you have the word relative, your final answer should always come with no unit. Okay? Actually, we have an easier way to calculate relative molecular mass. As simple as water. How do I calculate the relative molecular mass of water? It's actually your hydrogen, knowing that hydrogen mass is 1.0 times 2 hydrogen plus 1 oxygen, 16. You just basically need to add up the relative atomic mass of each element. Hydrogen, 1, oxygen, 16. So, the relative molecular mass of water is 18. Alright? Another example, if you have CH4. So what would be the relative molecular mass of CH4? Simple. Carbon, 12. So you have 12 over here. Hydrogen is 1. And you have 4 hydrogen over there. So solve the mathematics. The relative molecular mass of CH4 is 16. That's it. Simple. Alright, we don't really use the formula. That is actually how we calculate the relative molecular mass. Let's look into two examples. The first one, when you have bracket. When you have NH4 bracket 2 CO3, how do we calculate the relative molecular mass? So the relative molecular mass will be actually equals to the 2 need to times in. So you have 2 nitrogen and you will have 8 hydrogen. And we know that the relative atomic mass of nitrogen is 14. The hydrogen is 1. Carbon is 12. Oxygen is 16. So the relative molecular mass will be the total of each and every one of them. Nitrogen right now is 14. 14 times 2. Why times 2? Because you have 2 over here. Alright, bracket 2. So bring in the 2. Hydrogen right now is 1.0, the relative atomic mass. And nitrogen having 8 of them because 2 times 4. Okay, plus I have 1 carbon. Carbon is 12. And I have 3 oxygen. Oxygen is 16 times 3. And you can solve the mathematics easy peasy. The relative molecular mass of ammonium carbonate is 96 over here. Simple. Another example. What happens when you have a dot? What is the dot stand for in chemistry? Before that, the relative atomic mass of copper is 63.6. Sulfur, 32.1. Oxygen, 16.0. Hydrogen, 1.0. Okay? So that is all the relative atomic mass that you need to know. From this relative atomic mass, let's calculate the relative molecular mass. First and foremost, you have your copper. So copper is 63.6 plus with the sulfur, 32.1 plus with 4 oxygen. So it's 16 times 4. Okay? Plus with 5 H2O. Why am I still using plus? Because the dot over here does not represent multiplication. We don't times, we still plus, okay? It's still a plus over here. So what you need to do with the 5, you still times in. 5 times 2, so you have 10 hydrogen. 5 times 1, so you have 5 oxygen. Just kind reminder again, the dot over here still represent plus, okay? So, hydrogen is 1.0 and you have 10 of the hydrogen plus oxygen is 16 and you have 5 of the oxygen. Okay? Add everything up, press your calculator carefully, you will have the final answer as this. And since it's the relative molecular mass, your final answer shouldn't give you any unit. Simple. Just a kind reminder, the dot does not represent multiplication. It is still a plus. You are still adding them up. Alright? Do not multiply. Simple. That is how we calculate the relative molecular mass. Just a kind reminder again, since it's a relative, therefore your final answer should not come with any unit. So in this video, we talk about 3 things. The average atomic mass. We learn about the formula and how to calculate the average atomic mass. The relative atomic mass, the difference and the similarity between them. Last but not least is your relative molecular mass. Okay? And if you come across any examples or any question that I not managed to cover in this video, drop it in the comment below and I'll help you as much as I can. And if this video able to help you to understand this simple calculation, hit the like button and make sure to subscribe to my channel for more videos. I'll see you in the next video and thank you for watching.